Okay, the course is Electronic Devices and Circuit Theory. I am Mujhaid Hussain. Now we were studying about the BJT analysis. This is lecture number 3. So today we have to discuss effect of load impedance on gain. So we were studying about the BJT transistors, BJT amplifiers. Up till now the parameters were determined for the unloaded amplifier, with the input voltage connected directly to the terminal of the transistor. Up till now, there were no any load impedance at the output terminal of the transistor. So today we are going to study the effect of load on the gain of the amplifier. So we will introduce a load impedance, a load. Uh, so we will introduce a resistance RL at the output terminal, and we will use a source with the internal resistance RS. Up till now, since there was no any load resistance, so we named the voltage gain as no load voltage gain. As you see over here, this is the symbol of voltage gain, and NL shows no load voltage gain. And we know that the voltage gain is commonly taken as the output voltage to the input voltage. So in order to determine this voltage at no load, we have considered that there was no any load resistance connected at the output terminals of the BJT transistor. Now, after connecting a load resistance at the output terminals of amplifier, the voltage gain will be named as loaded voltage gain, and it will be obviously output voltage to the input voltage, and you see over here with RL. So when we connect RL, so it becomes the loaded voltage gain. Similarly, if we if we use a source having a source resistance RS, and simultaneously we connect the load at the output terminals of the transistor as well, then the resulting voltage gain will be another voltage gain that can be given by the ratio of output voltage V naught over Vs. This is the source voltage, and in this voltage gain we have included both
सर आपकी आवाज नहीं आ रही।
सर आवाज नहीं आ रही आपकी। यस सर, मुझे भी नहीं आ रही।
सर का कनेक्शन टूट गया शायद।
यही लग रहा है मुझे भी।
सर चले गए, कनेक्शन का प्रॉब्लम था।
सर चले गए?
रिकनेक्ट कर रहे होंगे।
हाँ
सर चले गए यार।
ये मीटिंग रिकॉर्ड हो रही है, ठीक है ना? मैं पहले बता रहा हूँ, रिकॉर्ड हो रही है।
हम तो पूछ रहे हैं कि सर कहाँ गए, हमने क्या कहा? हम कौन सा नजेबा बातें कर रहे हैं?
मैंने तो कहा नजेबा बातें कर रहे हो, कैसी बातें करते हो यार?
ये मर्जी है यार, सीआर आपकी। आप तो हर बात पे हमें टोकते हो यार। ठीक है, हम ठीक है, हम पढ़ने वाले नहीं है तो इसका क्या मतलब?
तुम पढ़ने वाले नहीं हो। 3.3 तुम्हारा जीपीए है, क्या बातें कर रहे हो
यार? आज
माइक बंद करता है। Okay, so there was an internet problem, so now we continue. So the voltage gain with the source resistance will be the ratio of V naught over the source voltage, and now with RL and RS. The important points to remember about these three different types of voltage gain are that the loaded voltage gain of an amplifier is always less than the no load voltage gain. We will see its proof in the coming slides. The loaded voltage gain is always less than the no load voltage gain. Another point is the gain obtained with the source resistance. The gain obtained with the source resistance in place will always be less than the obtained under loaded or unloaded conditions due to the drop in applied voltage across the source resistance. So there are three types of gains. First one was the no load voltage gain. Then we applied the load resistance RL, that was called as the loaded voltage gain. And then we added a source resistance, and that was known as AVS, the overall voltage gain. So the overall voltage gain will be less than the loaded voltage gain, and the loaded voltage gain will be less than the no load voltage gain for the same configuration. You, in other words, you can say कि आपका no load voltage gain will always be greater than the loaded voltage gain, and the loaded voltage gain will and no load voltage gain both will be higher than the voltage gain in which there is resistance at the source. The discussion we have seen in the last slides can be seen in the form of diagrams over here. In this first figure A, this amplifier configuration says that this is an unloaded situation in which you can see that output terminals have no any load resistance. So directly the voltage is being measured at the output of the transistor, at the collector of the transistor. No any load resistance is included. Similarly, at the input side, no any resistance. This is no load situation, so the no load voltage gain will be the voltage at the output V naught to the value of voltage at the input, and this will be highest among all these three. Similarly, the B figure is showing the amplifier configuration under the loaded conditions, and you can see that the resistance RL is added at the output side. Now the ratio of voltage V naught across this resistance RL to the input voltage will be the loaded voltage gain. Similarly, the third case is that you have used a signal source with the resistance Rs at the input side, because you apply the signal that you have to amplify. So the source that is providing, that is generating the signal, has an internal resistance Rs that is at the input side. So the output side also contain the load resistance. So the overall gain of this amplifier, that is V naught over Vs, the source voltage, it will be the overall gain of the amplifier. So if you see the C, this figure C is now analyzed, and its gain is found using different formulas and techniques that we have studied earlier. So we are considering this configuration given in this figure, the C part, for the further analysis. So if you apply the AC analysis steps to this configuration, that is, you make these capacitors as short circuit and make this VCC ground. So the overall circuit, make this voltage source as 0. So the overall this source signal will not cannot be 0. Only we have to make DC sources as short circuit, and these capacitors can be replaced by short circuit. This is the source signal which is applying the signal to the amplifier, so it will stay as it is. So by simplifying and rearranging the source and replacing the transistor with its RE equivalent model, so this is the final circuit after applying the AC analysis on the transistor. So you can see that this RL is now in parallel with this RC and the R naught of the transistor. So the output resistance will be the parallel combination of all these three resistances. Then you can make the simplifications that if R naught is very high, then you can say that RC in parallel with RL. If you take R naught as infinity, then you can say that you can ignore this R naught and take RC in parallel with RL. This will be your output resistance. Similarly, for the input side you can see if you look at these two terminals, so RB will be in parallel with beta times RE. So this will be your input resistance. Okay, now we come to the voltage gain. Since V naught will be equal to the current flowing at the output terminal multiplied by the resistance at the output side. So since the voltage polarity is opposite and the current is flowing in this direction, so we have taken this minus sign over here, and this is IC, which is beta times IB, and this is the output impedance RL prime, which is actually the parallel combination of RC and RL. So if you take this parallel combination and multiplied by the current flowing through the parallel combination of these resistances, it will give you the voltage across this parallel combination. So since we know that base current will be voltage over the resistance, input resistance, so V in over the voltage, the current flowing through this resistance will be the voltage across this resistance, which is V in, divided by this resistance, which is beta Re. So after substituting the value of IB in this equation, we get V out over V in as minus RC in parallel with RL over RE. We know that in the case of unloaded no load voltage gain, there was simple formula of minus RC over RE. No RL was there. So just only RL is included in the formula, that the load resistance will be in parallel with the collector resistance, and this will give you the value of gain. As you see that this is minus sign, so we know that in the case of common emitter configuration, the voltage gain is negative. The voltage gain show this minus sign shows that the output voltage will be 180-degree out of phase from the input voltage. Okay, so now we come to the third gain type, which is overall gain. Uh, so for this we have to consider the input side. We want to include the source resistance, so come to the input loop. We simply apply voltage division rule to the input side of this amplifier. This input loop contains a voltage source Vs, source resistance Rs, and resistance Rb. So this is a input loop. If you apply a voltage division rule, so these two resistances are in series with this source. So the voltage across this resistance Rb, which is V in, will be equal to the input impedance Z in divided by sum of the resistances Rs and Z in multiplied by the source voltage. So this is the formula which we have obtained from voltage division rule, that the input resistance divided by sum of input resistance plus Rs multiplied by the source voltage. Since we are measuring the voltage Vi across Z in, so Z in will be in the numerator में दोनों का सम होगा Z in and RS का, और सोर्स जो वोल्टेज आपको इन दोनों रेजिस्टेंसेस का जो सोर्स वोल्टेज अप्लाई हो रहा है वो आप यहाँ पे लिख देंगे। जस्ट ये अरेंज किया है, सो वी आई ओवर वी एस will be equal to Zi over Zi plus Rs. The overall voltage gain will be, as we have studied before, V naught over Vs, the ratio of V naught overall gain हम कैसे निकालेंगे, जो आउटपुट वोल्टेज है और उसकी रेशियो लेंगे टू द सोर्स वोल्टेज Vs. So V naught over Vs. We can rewrite this equation by multiplying it with V in and dividing it by V in. As you see over here, this is V naught, this is Vs, only we have introduced another multiplier which is Vi. वो हमने डिवाइड भी किया है Vi से और मल्टीप्लाई भी किया है। ये क्यों किया है, बिकॉज अभी आपको क्लियर होगा, because we have the equations of these two factors now. We have already calculated the equations for these two factors. As you see over here that this is V in over Vs, तो V in over Vs की जगह पे हम लोग ये equations put कर देंगे, and V out over V in is already calculated as the loaded voltage gain, so over here. So if you know the value of loaded voltage gain, you simply put it here and then multiply by this factor Z in over Z in plus Rs, you will find out the overall voltage gain. So these gains are interrelated with each other. As we stated earlier that this voltage gain, the overall voltage gain will be less than the loaded voltage gain. It is also proven from this equation as well, because in the numerator you have only Z in and in the denominator you have something greater than Z in. So this factor will always be less than 1. So you will get the answer of overall voltage gain will always, which will always be less than the loaded voltage gain. So this equation is mathematically, we can see that also showing that your left side of this equation is always be less than the right side. Okay, up till now we have studied the voltage gains only. For every configuration in the last chapters as well as in these online lectures, we have only studied about the voltage gain. But very interesting thing is that if you know voltage gain, so you can determine the current gain from the voltage gain. How? You can see in this slide that we have considered a two-port network. You see that in this box all of your configuration of the transistor and its resistances are enclosed in this box, and you have to determine three quantities of this system. If you have the information of three quantities that are input impedance, output impedance, and its no load voltage gain, then you can determine its current gain as well. So for each transistor configuration, the current gain can be determined directly from the voltage gain, the defined load and the input impedance. Just three informations आपको पता होनी चाहिए कि इसकी input impedance क्या है, output impedance क्या है और no load voltage gain क्या है. So we have this simple network that it has an input side where there are three quantities: input voltage, input current, and its input impedance. So we can apply Ohm's law at the input side, that the input current will be equal to input voltage divided by the input impedance. Similarly, the output current will be equal to output voltage over output load resistance. This minus sign shows that you are measuring the voltage in polarity that is opposite to the direction of current. Current is flowing upward and you are measuring the voltage in this polarity, so V naught the current will be in minus. Okay, so you have the equations of the input current and the output current. So ratio of output current to the input current will be your current gain. So substituting I naught and I in and rearranging, you get this equation. So this equation shows that V naught over V in, this is your voltage gain. So you have substituted voltage gain in place of V naught over V in. This minus sign as it is, and Z in over RL is also as it is. So from this equation you can conclude that we can find the current gain if we know voltage gain, the input impedance, and the load resistance. And very interesting thing that this current gain formula is not depending upon the system included in this box. It just depends on the quantities that are outside this box, that is RL, Z in, and its no load volt is its voltage gain, its loaded voltage gain. If you have information of these three quantities, then you can determine its current gain as well. So you can see the advantages of two-port system as we have determined the current gain. Further, we are going to study this two-port system approach in detail. This is a simple two-port network that has input side and output side, and this box encloses any configuration of the BJT transistor without load. So that's why we call this voltage gain as no load voltage gain. So when we look into this side, looking in this configuration, we make all the voltage sources at short circuit to find out the Thevenin equivalent impedance at these points. So that will be over Z naught. Similarly, this is the circuit in which we have substituted the internal circuits of the two-port system, because over here Z in might be R in. Similarly, Z naught is R naught, and the no load voltage gain can be written and adjusted in this form, that no load voltage gain times V in this will be the voltage source at this point. So if you have the information of input voltage, input impedance, output impedance, and voltage gain, you can draw the internal circuit of the two-port system. How can we justify this circuit? Look here that you have the equation. As you see that no load voltage gain is simply the ratio of V naught over V in. If you take this V into the below side of V naught, so V naught over V in will be equal to A V no load. तो no load voltage gain हमें पहले पता है कि वो V out over V in होता है, जस्ट उस V in को आप इस साइड पे ले आए हैं. So आपका जो आउटपुट वोल्टेज होगा, it is actually the product of no load voltage gain and V in. That's why we have written the product of voltage gain and voltage over here, and we have considered it as a voltage source because it is giving you something V, so it is a voltage source. So how we can say that V naught is same as AV times voltage, because under no load condition there will be no current, so I naught will be 0, because we are saying that this is a no load voltage gain. So at the condition of no load, the current I naught will be 0, so the voltage drop across this resistance R naught will also be 0. So all of this voltage will be appearing at the output side. So we can say that V naught will be equal to A times V when there will be no load. So no load current क्या होगा, 0 होगा. So इस R naught के क्रॉस तो कुछ भी ड्रॉप नहीं होगा, तो ये सारा का सारा जो voltage है, it will be appearing at the output side. That's why we have written this equation that V naught will be equal to A times V. Okay, the output impedance, as we defined earlier, that we, in order to find out the Thevenin equivalent impedance, we make short circuit all the voltage sources. So if you are looking at these terminals, make this voltage source as 0, so it will be grounded. So by looking at this terminal, you will see that Z0 will be equal to R0. Make this voltage 0, short circuit, and look at these terminals. So you will see that Z0 will be equal to R0. So this is the written over here. The output impedance is defined by setting V in equal to 0. So जब ये 0 हो जाएगा तो ये वाला नोड ग्राउंड हो जाएगा और आपके पास Z0 R0 के बराबर आ obviously यहाँ पे Z in जो है वो R in के equal है. So this is the actually introduction of two port system, and there are numerous advantages of this two port system as can be seen over here. So this slide says effect of source impedance on gain. Now we are going to study the effect of RS and RL one by one. Let's say only in this slide we consider a source resistance, how it affects the gain. So at the input side, if you simply apply a voltage division rule, so these two resistances are connected in series with a voltage source. So very easy to write a voltage division rule over here. That is the voltage across this resistance R in. The voltage across this resistance is VI. So VI will be equal to this resistance Ri over sum of these two resistances Ri plus Rs multiplied by the source voltage, that is Vs. So very simple. If you take this Vs to the denominator of Vi, so Vi over Vs will be equal to Ri over Ri plus Rs. That will be used in the next slide. Now this equation says, this slide shows the effect of load impedance on gain. In the previous slide we considered the effect of source resistance. Now we are considering the effect of load resistance. So if you add a load at the output terminals, so then apply a voltage division rule at the output side. So V0, that is the voltage across this load resistance RL. So V0 will be equal to RL over RL plus R0 multiplied by this voltage source. So then you take this V into the denominator of the left side of the equation. So this equation becomes that voltage gain will be the load resistance over sum of all RL plus R0 into no load voltage gain. Now we have both equations considering the effect of RS and RL. So we have written over here that the effect of RL that we have studied in the previous slide, that RL over RL plus R0 into the no load voltage gain, this will be the loaded voltage gain. And in the previous slide we have also studied the effect of RS as VI over VS as RI over RS. Now we are going to use these two equations to find out the overall gain. So the combined effect of R and RS using two-port network system can be determined by rewriting this equation and multiplying it by V in and divided by V in. So by putting these two expressions as we have found earlier, V0 over Vi is actually Ri over Ri plus Rs. V0 over Vi. So by putting the terminologies that we have derived in the previous slides, then we find overall gain as the product of these terms. So you can see that these two factors are less than 1. So when they multiply with the no load voltage gain, so the overall voltage gain will be lesser than the no load voltage gain. Now we have the current gain. This is the last slide. The current gain, as we discussed earlier, when we can find it by the voltage gain. So simply the current gain will be the output current to the input current. So output current is simply V naught over RL. It is minus because the polarity of voltage is opposite to the direction of current. Input current will be the input voltage to the input impedance. When you rearrange this, so this is the voltage gain. Voltage gain, input impedance divided by the load resistance will give you the current gain. And current gain is also this is the current gain without considering the effect of RS. If you consider the effect of RS on the input side of the transistor, then you add these two resistances Rin and RS and write instead of Zi. You can see over here. If you want to find out the current gain by considering the source resistance, then you put the voltage gain by considering the source resistance over here and include RS in the numerator. Over here only Z in was there, so now RS can be written and RL will be same. So this is the overall voltage gain and this is the overall current gain by considering both RS and RL. So if students, if you have any questions, then please raise your hands, then we discuss your questions one by one.